Now we'll have a look at revision exercises. That's chapter 13. That's question 19, which has in part 1 a function, and they want us to find the derivative of this function. So it's a function of theta. It's given as sine 2 theta all over 1 plus cos 2 theta. Right, so what we'll do here, seeing as how there are two separate functions of theta, one top and one bottom, we'll use the quotient rule. Now we'll use so it's going to be bottom div top minus top div bottom all over the bottom squared. Okay, so let's go back in now and fill in those missing bits. We have bottom 1 plus cos 2 theta. Differentiation at the top will be 2 cos 2 theta, using the chain rule there, minus the top, sine 2 theta, by differentiation at the bottom, it's going to be 1 goes to 0, cos goes to minus sine, and it's going to be minus 2 because of the chain rule, that's sine 2 theta. All over bottom squared, and that's just 1 plus cos 2 theta in there. Okay, let's do a tidy up on the top line. I'm going to have 2 times cos 2 theta, hopefully out the brackets, plus 2 cos squared 2 theta, minus and a minus, a plus there, minus 2 sine squared 2 theta. That's all over 1 plus cos 2 theta all being squared. Now, important point to remember from our page 13 in the log tables is that cos squared of anything, sine squared of anything, same angle, must be equal to 1. Okay, so same angle there. You square the cos of it, square the sine of it, and add them together. So let's go back here and notice that we've got 2 times cos squared of an angle plus 2 times sine. Alright, top line, 2 cos 2 theta plus 2 times cos squared 2 theta plus sine squared 2 theta. That's all over 1 plus cos 2 theta being squared. Okay, and again, all this guy in here is just 1. Okay, that's from page 13 over here in the logs, page 13 logs. Okay, going back, so what do we have on the top line? We have 2 times something, it's 2 times cos 2 theta on the left, plus 2 times just 1 on the right. So you can factor out that 2, and on the bottom I've got 1 plus cos 2 theta being squared, which is actually, if you look at the bracket here, it's the same thing as the bracket below. The guy in the bottom is being squared, so I'll just knock off one of him. Right, equals him once, so that's just going to be 2 all over 1 plus cos 2 theta. Okay, and that's the answer for part 1. Part 2 then goes on to ask us to write that f dash theta in different form. So we have to show f dash, the derivative of f with respect to theta, can be written in the form sec to the power of a times r of b theta. So it can be written in the form sec to the power of a, and b times theta is your argument. So a and b are given as integers then. Okay. Remember again from page 13 in the logs that sec theta, this thing sec theta, is just 1 over our old friend cos theta. Okay, so remember that guy. Also from page 13 in the logs. Right, so if we can keep that in mind as we go down, we have from part 1 the derivative of f is equal to 2 over 1 plus cos 2 theta. And I'm going to focus in here on this double angle cos 2 theta. So I'm going to need to get that to become a sec theta somewhere along the line. Just sec to the power of something times something theta. So it's got 2 over 1 plus cos 2 theta, and I'll need to refer to my page 14 double angle formulas, see if I can get anything out of this. And this does come with trial and error. There's no hard and fast tricks or rules. You just have to kind of get a knack for it, and with practice it does get easier. Okay, so cos 2 theta, there's a couple of options I have on page 14. There's 4 different options containing cos 2 theta. What I'll do is I'll just take the simplest looking one first, which is the first appearance of it. That's cos squared theta minus sine squared theta. It's a formula for cos 2 theta. So what I'll do is I'll rewrite my derivative, except I'll put in that double angle formula, convert it to single angles. So 1 plus cos 2 theta now becomes cos squared theta minus sine squared theta. Okay. Now I had before that cos squared theta plus sine squared theta is equal to 1, so maybe I can use that a little bit over here. Cos squared of an angle plus sine squared of an angle, same angle, must be equal to 1. Okay. Now if I bring the sine squared theta over, so cos squared theta and so now is equal to 1 minus sine squared theta, and you'll notice there that on the bottom line of my derivative I've got 1 minus sine squared theta. Okay, I know it sounds easy when I'm doing it like this, but trust me, you do get better at these with practice. So 2 all over, well, the highlighted stuff now is just cos squared theta. There's another cos squared theta left, and then what is really on the bottom is just 2 all over 2 cos squared theta. Okay, now you notice that there's a common factor, so I can do a bit of crossing out here. Got 2 top and bottom, so there's just 1 there. That turns out to be 1 all over, and just cos squared theta, which is, if we refer back to the page 13 over here, we have that is just equal to sec squared theta. So that's the final answer. A turned out in the end to be just 2, and B is just 1. Both integers.